November 12, 1942, Richmond, California. A fully constructed cargo ship measuring 441 feet in length and weighing 28,490,000 sat poised to launch into San Francisco Bay from the gates at Permanente Metals Corporation, Yard Number 2. This vessel had been put together in only 4 days, 15 hours, and 29 minutes. Traditionally, master shipbuilders took anywhere from 6 to 8 months to construct ships of comparable size, a practice that dated back to before the American Revolution. But here, an entirely built Liberty ship awaited deployment. More than 1,000 individuals withdrew from the side of the SS Robert E. Peary. They were not seasoned shipwrights or veteran maritime artisans, but rather secretaries, agricultural workers, homemakers, and general laborers who had acquired welding skills just a few weeks prior. Dignitaries, members of the press, and rival shipyard owners had assembled to observe an event that would spark a sweeping shift in the world of industrial manufacturing. An organized revolution in American engineering innovation was about to resonate for generations. The equation for Allied success was now being composed not through strategies of war, but through production records that would overturn every conviction that shipbuilding professionals maintained about speed limits, timelines, and what industry could achieve. This shift began on December 27, 1940, when Henry J. Kaiser entered into his first contract to build ships. Kaiser, a man who never constructed a ship, never oversaw a shipyard, and who had spent his professional life handling earth-moving and concrete work for vast dam projects in the American West. Still, now stood a 58-year-old construction tycoon, newly committed to the United States Maritime Commission to deliver 30 cargo ships for the British within 2 years. Veteran shipbuilders dismissed him as an unrealistic profiteer. Todd Bath Iron Works, among the country's oldest shipyards, had hesitantly entered into partnership with Kaiser for this job, believing that their skill would offset his lack of expertise. What none recognized was that Kaiser's inexperience in ship construction would become his strongest asset. In attendance was William Francis Gibbs, America's most esteemed naval engineer, whose company Gibbs & Cox had devised the Liberty ship blueprints from British models. Gibbs had designed more ships than Kaiser had likely viewed in his lifetime. The movement from doubtful opposition to full-fledged transformation commenced in the design offices at Todd Shipyards in New York. When Kaiser and his technical staff reviewed standard shipbuilding processes early in 1941, they saw at once that those practices would not fulfill the needs of wartime production. Kaiser's principal engineer, Clay Bedford, had recently visited a Ford Motor Company plant in Detroit a few weeks before. Bedford observed auto frames traveling along the production line, with staff attaching finished parts at each stop. He went back to California persuaded that entire ships could be built in just this fashion. Older shipbuilders thought comparing ships to cars was nonsense. The initial major disruption arose from Kaiser's idea to completely forego riveting. Standard shipbuilding employed rivets, heated iron rods pounded through overlapping steel panels to unite them. A team of skilled riveters, operating smoothly, could possibly insert 100 rivets a day. Constructing a Liberty ship in this conventional manner used close to 1 million rivets. Kaiser suggested switching to electric arc welding, a technique he had perfected during the construction of pipelines throughout the American West. Vice Admiral Emory Land, who presided over the U.S. Maritime Commission, received Kaiser's plan with considerable doubt. His letters, preserved in the National Archives, depicted the reaction among naval professionals. Welding at this magnitude had never been reliably demonstrated on ship hulls. The Royal Navy did not permit its use on warship hulls. Kaiser intends to risk America's logistical routes on a process not yet proven. Still, Land noted a sense of urgency. German submarines and naval raiders were destroying Allied vessels faster than traditional builders could replace them. In 1941 by itself, nearly 3.6 million tons of Allied ships were lost to the depths from all causes. Britain quite literally was being starved. U.S. yards limited to standard practices took an average of 230 days to produce a single freighter. At this rate, the Allies would lose the struggle for the Atlantic before industry in America could make a decisive difference. Sanctioning Kaiser's deal was not an act of faith, but of sheer need. The Richmond yards emerged from barren mudflats over the course of January to December 1941. Kaiser's teams, versed in dam and infrastructure building, assembled a plant that dismayed seasoned shipbuilding engineers. Instead of the massive gantry cranes and longitudinal slips typical of historic yards, Richmond's facility offered something entirely new. Its layout was akin to a car factory. Spacious prefabrication zones surrounded 7 side-by-side building ways. Rail lines crisscrossed the grounds, meant for hauling immense steel assemblies up to 150 tons. Giant cranes capable of hoisting full ship segments sat at 100-foot intervals. John Riley, principal naval architect at Bethlehem Steel and a 30-year shipbuilder, toured Richmond in May 1941. His confidential evaluation filed afterward blended technical critique with reluctant respect. Kaiser has violated all principles of efficient yard organization acquired over 30 years. His prefab zones are oversized. His crane power vastly exceeds what's necessary. His building ways aren't long enough. Nevertheless, it's undeniable the site is tailored precisely to his purpose: rapid assembly of prefabricated segments. The influx of the workplace's new hires signaled the next stage of the revolution. Old-fashioned yards hired mainly from port towns, where expertise was handed from one generation to another. Kaiser ran advertisements nationwide, offering pay rates 20% above prevailing industry standards and pledging to train any willing candidate. The initial arrivals came to Richmond in August 1941. The breakdown of intricate technical work into repeated simple jobs, copied from the assembly line model, delivered unexpectedly powerful results. By October 1941, more than 10,000 people worked at Richmond, but fewer than 200 brought any previous maritime background. In conventional welding, apprentices trained 4 years to master all-around techniques. At Kaiser's instruction sites, trainees learned particular methods for specific duties in about 2 weeks. The workforce only needed to know, for instance, how to weld the vertical seams of partitions, or the flat deck seams, or the curved side panels. They repeated these operations continually. As shop floor skills grew towards the end of 1941 through early 1942, an unforeseen pattern emerged. Liberty ship assembly times began dropping at a rapid pace. Kaiser's first Liberty ship demanded 197 days to launch. The second ship required 169 days. The fifth ship took 128 days. The 10th took 97 days. By the spring of 1942, Richmond was turning out completed Liberty ships every 70 days on average. Established builders viewed this with increasing dread as the mostly green team reached output rates equal to expert, tradition-bound workers. The prefabrication strategy, which long-established players had rejected, now showed its effectiveness. Rather than assembling ships in a linear fashion from base to top, Kaiser's plants made entire modules at the same time in dispersed workshops. While one team put together the bow, others would fabricate sterns, superstructures, machinery spaces, and internal barriers elsewhere simultaneously. As soon as these were done, heavy cranes placed them on the building ways for welders to join them into a final vessel. Albert Wooding, production chief at Richmond Yard 2, described these advancements in a 1943 Fortune magazine interview. In the classic ship construction method, you can't fit the engine until there is an engine room. You can't construct the engine room until the main hull is completed. Everything unfolds in a predetermined sequence. With Kaiser's method, simultaneous progress is possible. As one team welds hull plates, another assembles the engine on a different floor. When both pieces are finished, we drop the ready engine into the ready engine room and weld them together. Jobs that used to last several weeks now finish in just hours. The data from concurrent production revealed a level of efficiency traditionalists found inconceivable. Where a classic yard might put 50 men on an engine for 3 weeks inside a tight, incomplete hull, Kaiser's prefabricated method put 200 workers on the full engine and support structure in wide-open workshops for 5 days, then maneuvered the entire assembly into position with a single, 8-hour use of the crane. What further alarmed shipbuilding authorities was the easy abandonment of meticulously followed procedures. Ships had always come from detailed plans defining every element. Kaiser adopted simplified diagrams providing just the core measurements, leaving decisions to shop floor judgment. To time-honored experts, this was foolhardy. To Kaiser, it was adaptability. Vice Admiral Howard Vickery, deputy chair of the Maritime Commission with a lifelong naval background, at first resisted Kaiser's simplified drawing standards. His shift from opponent to backer, recorded in commission minutes, demonstrated that productivity could change minds when theory did not. In January 1942, I challenged Kaiser's wishes to reduce design blueprints. Ships aren't cars. Ship construction relies on precise detail. By March, Kaiser's teams surpassed conventional builders by 40%. By June, that lead had grown to 70%. I discovered that striving for perfection could stand in the way of getting enough done. Kaiser's ships lacked beauty, but they sufficed, and an adequate ship could haul more goods than a flawless one that was not yet launched. During the spring and summer of 1942, as construction efforts accelerated, a spirit of rivalry grew among Henry Kaiser's 7 shipyards located throughout California, Oregon, and Washington. Edgar Kaiser, Henry's son and the company's vice president and general manager, supervised all Kaiser-owned shipyards, with a particular emphasis on the 3 in the Pacific Northwest, and directly ran the Oregon Shipbuilding Corporation in Portland. The Richmond Shipyards in California were administered by Clay Bedford. These two energetic and competitive leaders initiated an unofficial rivalry, each striving to outdo the other at ship construction speed. Throughout the fall of 1942, the Portland versus Richmond competition gained public attention. Newspapers reported each progress update as if announcing sports results. Speed records fell frequently until Oregon Shipbuilding completed the Joseph N. Teal in just 10 days in September 1942. Ultimately, Vice Admiral Vickery intervened to halt the speed contests, labeling them as mere stunts that drew focus away from the real objectives of production. Nevertheless, the race had already achieved Kaiser's aim. Employees in all 7 shipyards had become convinced that remarkable speed was not only possible, but anticipated. A defining event occurred in November 1942. On a visit to Richmond to observe production, Vice Admiral Land made an incidental remark to the press, which Clay Bedford happened to overhear. Land commented that while Liberty ship output had improved drastically, recent records still seemed unimpressive when compared to what could be achieved through mass production in other sectors. Bedford interpreted this as a provocation. He suggested to Vice Admiral Land that Richmond Yard No. 2 should attempt constructing a full Liberty ship, from beginning to launch, in less than 10 days, thereby having Joseph N. Teal's record. Though skeptical, Land consented to the attempt, provided it did not interrupt normal production. Bedford chose the 47th keel at Yard No. 2 for this challenge. The vessel was to be christened SS Robert E. Peary after the famous Arctic explorer. Commencing at 12:01 a.m. on Sunday, November 8, more than 1,000 laborers working in highly organized rotations set out to try something never before attempted in maritime construction. Prefabrication techniques reached their zenith during this dockside assembly. Every critical part was constructed, checked, and placed in readiness ahead of the keel's arrival on the slipway. The bow, made up of 50-plus separate elements, was already welded together, fitted with anchors, chain compartments, and forward crew accommodations before being incorporated. The stern came ready with its steering equipment, propeller shaft, and rear crew quarters. The 4 full cargo bays, each a massive steel rectangle, were held, balanced, and ready for installation. The ship's engine, a triple expansion steam plant weighing 140 tons and manufactured by Joshua Hendy Iron Works in Sunnyvale, was secured on its frame and tested before shipment. While the majority of shipyards typically assembled from the bottom up over many months, Kaiser's method involved uniting densely prefabricated units into nearly finished ships in a matter of days. 4 days from start, the hull had been assembled, the engine installed, deckhouses set, holds fastened, and the steering in place. At 3:30 p.m. on Thursday, November 12, just 4 days, 15 hours, and 29 minutes after the first keel was laid, the SS Robert E. Peary descended the rails into San Francisco Bay. The vessel entered service on November 15, establishing a further milestone at 7 days, 14 hours, and 32 minutes from start to delivery. The event drew a crowd of naval authorities, military leaders, rival shipbuilders, and journalists nationwide. Numerous attendees assumed they would either see failure or a ship superficially complete but internally unfit for duty. Instead, they witnessed a fully functional vessel that required only negligible final outfitting prior to deployment. Vice Admiral Land attended the inauguration, offering brief comments recorded by newsreel reporters. His speech articulated the shock among maritime leaders forced to confront a new reality. 6 months prior, I would have considered this impossible. The accumulated wisdom of shipbuilding, gathered over 3 millennia, said a seaworthy ship could not be made in 5 days. Henry Kaiser has rendered that wisdom obsolete. Henceforth, the U.S. Maritime Commission will require all contracted yards to adopt these methods. The immediate psychological effect on traditional shipbuilders was significant. Just a year and a half earlier, the same yards dismissing Kaiser as inexperienced now sent their engineers to observe his processes. In December 1942, New York Shipbuilding Corporation's president, representing one of the nation's most venerable yards, toured Richmond. His confidential report, presented to his board, exhibited a complete reversal in attitudes toward conventional shipbuilding. Kaiser has realized what we viewed as unattainable by refusing industry limits. He approached shipbuilding as a manufacturing task, not a craft handed down through generations. He emphasized simplification where we pursued perfection, standardization where we specialized, and mass training of novices rather than nurturing inherited mastery. Now, ships are produced in 1/10 the time for 2/3 the traditional cost. We are faced with the choice of adapting to these changes or resigning ourselves to irrelevance. By early 1943, Kaiser's model had revolutionized American ship production. There were 18 yards using prefabrication and welding to build Liberty ships. The average build time had dropped from 230 days to merely 42 by mid-1943. The United States was launching 3 Liberty ships every day, producing more shipping than German U-boats could destroy. Yet, perhaps the most disruptive blow to established shipbuilding came from the composition of Kaiser's labor force. The tens of thousands of women, minorities, and previously inexperienced men and women who assembled these vessels undermined the power of the decades-old guild system. At the height of the effort in 1944, Kaiser's 7 shipyards had a workforce of about 196,000. Of this number, women accounted for more than 40,000, a highly significant portion of the industry's female labor representation. By mid-1944, women made up 27% of Richmond's production staff. Just the 3 Northwest yards alone together had over 31,000 women working there by 1944. African American employees numbered into the tens of thousands too, working as welders, fitters, crane drivers, and in supervisory duties, a level of workplace diversity striking for wartime America. This opening up of skilled industrial jobs carried consequences that extended well past the war. By revealing that intricate assembly could be mastered by trained staff instead of relying on generational craftsmanship, Kaiser's yards shook long-standing views about labor, expertise, and industrial practice. Christmas of 1943 further illustrated Kaiser's radical industrial culture. While older shipyards granted brief holiday breaks, Kaiser's sites maintained steady output, but backed this up with holiday observances showing appreciation for workers' efforts. At Richmond, management arranged festive dinners in the plant cafeterias, offering turkey, ham, and all traditional fixings to workers free of charge. Nearby churches sent choirs of carolers, the Richmond Municipal Band performed, and Kaiser himself appeared at the yards to personally shake hands and thank employees for their contributions. By the summer of 1944, Kaiser's 7 sites had delivered more than 800 Liberty ships. The methods he pioneered were being used far beyond his own plants. Altogether, by that point, the 18 American Liberty yards had finished 2,400 ships. Victory ships, beginning in 1944, were constructed in the same fashion using the prefabrication and welding system. Network-wide, American shipyards constructed over 5,500 vessels between 1941 and 1945, amounting to roughly 53 million tons. This output was astonishing to those who saw it then and remains remarkable today. Commander Joseph Kenworthy of the Royal Navy, working for the British Admiralty delegation in Washington, closely monitored U.S. construction. In official reports now declassified from the 1980s, he detailed the British reaction to the scale of America's enterprise. The U.S. is creating merchant ships at a pace exceeding that of the whole remainder of the planet. Kaiser singly turns out more tonnage monthly than the entire British shipbuilding sector. These methods are rough to Admiralty standards. The vessels are plain, but they are seaworthy. They haul freight, and their number is immense. The Royal Navy has for years constructed the world's finest warships through painstaking artistry, taking years for each. The Americans, in contrast, create sufficient craft in mere weeks. Sufficient, multiplied by thousands, overcomes perfection produced just dozens of times. However, perhaps the most extraordinary element of Kaiser's transformation lay in the events following the conclusion of the war. Conventional commentators anticipated a sharp decline in shipbuilding, expecting the workforce surge to subside and thousands of expensive facilities to be left idle. This projection turned out to be accurate in part. Liberty ship manufacturing ceased in September 1945. By December, the number of Kaiser's employees had dropped from 200,000 to under 20,000. By the spring of 1946, the once bustling Richmond Shipyards that had topped 100,000 workers were largely deserted. Still, the expertise cultivated during the urgent wartime project endured. The innovative methods of prefabrication, welding, and parallel assembly introduced by Kaiser were later generally adopted by shipbuilders across the globe. In the 1950s and 1960s, Japan and South Korea revitalized their shipbuilding industries by examining Kaiser's Liberty ship operation and incorporating his techniques as the backbone of their shipyards. The enormous shipyard complexes in Ulan, South Korea, and Nagasaki, Japan, which would come to lead the world in shipbuilding for many years, were direct offshoots of the revolutionary methodologies at the Richmond yards. John Bunker, who was a maritime history professor at the State University of New York Maritime College, encapsulated Kaiser's enduring impact in his authoritative research published in 1972. Kaiser began constructing ships with no roots in the field, unfamiliar with shipping customs, unfettered by prevailing industry views, and willing to use manufacturing strategies that traditionalists saw as unsuited for vessel production. Within just 36 months, he launched more ships than the United States had during the previous 100 years. More significantly, he permanently changed the global methodology of ship production for the rest of the 20th century. The segmented construction, prefabricated components, and welded assemblies developed by Kaiser have since become worldwide norms. Today, every leading shipyard, whether assembling container ships in Korea, oil tankers in Japan, or passenger liners in Europe, relies on lead practices descending from the Liberty ship project. The size of Kaiser's accomplishment is evident in data that display both the scope of the initiative and its extraordinary success. Records document the construction of 2,710 Liberty ships at 18 U.S. yards between 1941 and 1945. Averaging 1.8 ships per day during the highest output periods. Of those, the 7 yards operated by Kaiser built 1,490 ships, accounting for 27% of America's wartime merchant shipping under maritime commission agreements. The average time per vessel fell from 230 days for the earliest Liberty ships in 1941 to just 42 days in 1943, with the Robert E. Peary setting a record of 4 days and 15 hours from keel laying to launch. As workers grew adept, their productivity soared. It initially took around 1.1 million worker hours to complete a Liberty ship, but by 1943 the average required fell to roughly 486,000 per ship. Kaiser's top-performing locations, Richmond numbers 2 and 3, managed to finish ships with as little as 350,000 worker hours by maintaining continuous three-shift operations and maximizing the use of prefabricated modules. Cost savings kept pace with the shorter construction timeline. The first Liberty ships ranged from about $1.75 to $2 million apiece, but even as wages and material costs rose, average ship cost in 1943 declined to $1.8 million, reflecting gains in productivity and experience. Each Liberty vessel displaced 14,245 tons when fully loaded and was capable of hauling 10,800 tons of freight. On a single trip, these ships could move 2,840 jeeps, 440 tanks, or 230 million rounds of ammo. Outfitted with triple expansion steam engines chosen for reliability and simplicity of manufacture, these vessels maintained a top rate of 11 knots, which sufficed for operations within escorted convoys. Training programs proved equally efficient. Kaiser's educational institutions taught workers specialized jobs in about 2 weeks. The shortest training cycle readied spot welders to be effective in only 10 days. More involved roles such as crane operators or ship fitters required 4 to 6 weeks of preparation. In contrast, traditional shipbuilding apprenticeships demanded 4 years to reach basic ability and a decade to achieve master craftsman rank. The core distinction centered on specializing versus thorough all-around training. Classic apprentices covered the full range of shipbuilding, whereas Kaiser's personnel became highly skilled at limited, repetitive operations. Liberty ship loss rates during wartime combat highlighted the ship's effectiveness despite early doubts about rapid manufacturing approaches. Out of 2,710 Liberty ships constructed, around 200 were destroyed due to enemy intervention, yielding a 7.4% loss rate. This compared positively with pre-war merchant fleet losses and indicated that welded construction, though initially doubted, indeed delivered seaworthy ships. Some vessels did suffer from structural flaws attributed to weld issues. There were 3 instances of Liberty ships breaking in two due to brittle fracture, representing 0.11% of ships built. Across the fleet, almost 1,500 significant brittle fractures were recorded, but total splits were infrequent. These experiences led to advances in welding methods and material quality that eliminated the issues by 1944. Long-term performance data best validate the resilience of Kaiser's shipbuilding processes. Although Liberty ships were intended as temporary boats meant to last just 5 years, they frequently exceeded those expectations by decades. The SS John W. Brown, constructed in 1942, remained an active museum exhibit in Baltimore as of 2024, marking 82 years since it was built. The SS Jeremiah O'Brien, which was finished in 1942 as well, is preserved in San Francisco and actually sailed independently to Normandy in 1994 to join the 50th anniversary celebrations of D-Day, 5 decades after its launch. The SS Helles Liberty, another Liberty ship, functions as an anchored museum piece in Greece. Post-war, the trajectory of many Liberty ships went far beyond what their design lifespan anticipated. Out of roughly 2,510 units that outlasted the war, about 835 stayed in the commercial fleet through the 1960s. Numerous vessels found new life via foreign shipping outfits and remained operational into the 1970s. The SS Albert MBO, which was the final Liberty ship delivered on October 30, 1945, avoided being scrapped. It was sold in 1964 for $65,557, repurposed as the Star of Kodiak Fish Cannery in 1965, and still exists as the landlocked headquarters of Trident Seafoods in Kodiak, Alaska 8 decades after it was launched. The broader economic effects of the Liberty Ship project spanned the whole American industrial landscape. The enormous requirement for steel led to increases in steelmaking capacity, especially on the West Coast, where Kaiser had the Fontana steel mill constructed to support his yards. Completed in 1942, 5 months ahead of plan, the mill generated about 700,000 tons of steel per year, making California a significant steel-producing area for the first time. Magnesium necessary for incendiary weapons and aluminum vital for aircraft production were manufactured at Kaiser-owned plants created to supply the interconnected war industry. Job creation rippled through communities throughout California, Oregon, and Washington. Richmond, California expanded from 23,000 residents in 1940 to upwards of 100,000 by 1943, entirely driven by shipyard work. Kaiser established Benport City in Oregon to house the workforce, making it the state's second-largest city with a population topping 40,000, almost all tied to shipyards or related industries. These rapidly constructed settlements, even if impermanent, underlined the powerful influence of focused industrial spending. Medical system improvements appeared as an unexpected legacy of Kaiser's shipbuilding achievements. In order to supply healthcare for his vast workforce, Kaiser collaborated with Dr. Sidney Garfield to craft prepaid medical plans that eventually became Kaiser Permanente, which grew into one of the nation's principal health organizations. The prepaid and preventive medical system championed in Kaiser's shipyards left a mark on American healthcare for decades, serving over 12 million people by the start of the 21st century. Lessons learned by the labor force in these shipyards fueled a lifetime of accomplishments in peace. The facilities gave many young individuals, and particularly women and minorities, the chance to develop talents otherwise inaccessible via traditional work paths. These opportunities had a lasting impact throughout their lives. The technical breakthroughs realized during the Liberty Ship campaign extended into fields beyond ship construction. The welding expertise developed through wartime necessity became a standard in structural steel building, petroleum industry equipment, and pressure vessel production. Prefabrication methods from Richmond influenced how homes, bridges, and industrial sites were assembled. The strategies of parallel assembly, streamlined designs, and accelerated training evolved into basic tenets in the teaching of operations management and industrial engineering. Professor Michael Porter of Harvard Business School, in a 1985 study on U.S. manufacturing competitiveness, called the Liberty Ship Initiative an essential illustration of rapid capacity building. Kaiser proved that industrial output was not a static quality, but something that could be rapidly increased in response to acute need. At the beginning of World War II, the U.S. merchant shipbuilding sector was underdeveloped. Within 2 years, U.S. facilities surpassed the combined output of the rest of the world. This demonstrated that manufacturing infrastructure, labor proficiency, and production methodologies could be created with exceptional speed through effective organization. This insight has implications beyond emergencies in wartime. It indicates that perceived limits of industrial potential are often more about inherent organizational or conceptual restraints than about technical or material barriers. The shift in mindset produced among industrial strategists and engineers by the Liberty Ship Initiative was as important as the tangible output of ships themselves. Before Kaiser's influence, those in manufacturing generally accepted limitations regarding productivity rates, training needs, and operational frameworks. Kaiser's experience showed that accepted norms could be mistaken, and that achieving remarkable results required challenging deeply held beliefs. The story of the Liberty Ship ultimately serves as evidence of a deep truth about what humans can do and what industry can achieve. The ships themselves, though vital to the Allied victory, were less important than what their building demonstrated. Regular individuals, when provided with training and opportunity, were able to produce remarkable outcomes. Items of complexity that once took years of skilled craftsmanship could be assembled in a matter of weeks through organized procedures. Industries that had resisted transformation for generations were able to be changed dramatically in only months when innovation met necessity. Admiral Chester Nimitz, who led the Pacific Fleet, considered the strategic significance of America's maritime output in his memoir published in 1960 after the war ended. "We traversed 5,000 miles of Pacific Ocean, supplied by vessels constructed at a pace the enemy could not match in sinking." Planners in Japan's military thought American industrial strength was notable but had limits. Thinking that sinking enough ships would eventually cause a breakdown in American supply lines and force us to negotiate, they miscalculated. They did not foresee Henry Kaiser. By 1944, we replenished shipping losses at a rate faster than the Japanese could destroy them. The numbers of attrition worked in favor of those making 3 ships daily over those sinking 2 per day. Industrial might, rather than heroic valor, was decisive. Victory in the Pacific War was achieved in the factories of Richmond, Portland, and Baltimore just as much as on the battlefields of Iwo Jima and Okinawa. In the final analysis, Kaiser's most significant accomplishment was not simply the 1,490 ships his factories delivered, but the shift he inspired in perceptions of what industry could do. The Robert E. Peary, assembled in under 5 days, gave unmistakable evidence that long-standing traditions were not infallible, that established ideas could be challenged, and that significant advances required bold new thinking. The maritime establishment that had dismissed Kaiser as a naive outsider in 1940 would spend years after 1945 studying and adopting his methods. The young men and women who learned skills in welding, fitting, and fabrication brought those abilities and their newfound confidence into civilian occupations that helped rejuvenate the American economy after the war. Strategies developed to meet wartime emergencies became standard practice in peacetime and shaped production methods across a wide array of industries globally. The account of how one civilian's methods brought Liberty ships into being in days instead of months is, at its heart, a tale of transformation by demonstration. It shows that the most significant advancements often originate with those not confined by tradition, that making progress depends on questioning presumed boundaries, and that human ability can surpass standard expectations when properly motivated and organized. The workers in Kaiser's shipyards were not exceptional people. They were average individuals accomplishing remarkable feats because someone believed in them and organized systems that allowed them to show what they could do. That example set in the Richmond Shipyards and affirmed by the completion of 2,710 ships remains important wherever businesses confront challenges that accepted wisdom deems impossible. Most of the Liberty ships are gone today, dismantled decades ago or lying on ocean bottoms. However, the changes they signified still survive in today's shipyards, in all manufacturing centers that employ prefabrication, in every educational program that prioritizes quick skill acquisition over slow mastery of broad knowledge, and in every manager who doubts whether impossible truly means it cannot be done or merely that no one has solved it yet. That stands as Henry Kaiser's lasting contribution etched not into metal but into the evolved understanding of what determined people can achieve when no longer limited by convention and inspired to do what the experts believe cannot be done. From December 1940, when he agreed to his first contract with no background in ship construction, through November 1942, when the Robert E. Peary was launched after fewer than 5 days of work, to September 1945, when the last Liberty ship was completed, Kaiser showed that industrial leaps forward happen through a total rethinking of what can be done, not through slow stepwise changes. The 2,710 Liberty ships completed between 1941 and 1945 not only transported cargo across seas. They delivered proof that human inventiveness, when freed from old ways and driven by need, is capable of making the impossible a reality.